Hello everyone, this is Balavenkatesh Bathrinarayanan, a graduate student at the ECE department at University of Florida. Now, I will be talking about my pattern recognition project, Fingerprint Recognition, done under the guidance of Dr. Dapeng Oliver Wu. So what is a fingerprint? The pattern feature that is present on a single finger is called a fingerprint. Every person has unique fingerprints, which is different from any other person's fingerprints. Many furrows and ridges together form a fingerprint. These furrows and ridges exhibit similarities locally. Thus, these cannot be used for fingerprint recognition. Minutiae, which are defined as abnormal points on ridges, are used for fingerprint recognition. Termination and bifurcation are the two kinds of minutiae that are predominantly used for fingerprint recognition. Termination is where a ridge ends immediately. Bifurcation is where a ridge divides into two ridges. A fingerprint recognition system has two functions, namely verification and identification. Verification is the process of authentication of a person based on his fingerprint. On the other hand, identification is the process of specification of the identity based on his fingerprint. At the system level, a fingerprint system has three stages. The first level is the sensor, which acts as the input. The second level is the minutia extractor, which processes the acquired fingerprint and extracts minutia features. The last level is the minutia matcher, which will match two fingerprints and display a matching percentage between the two fingerprints. A block diagram of the fingerprint recognition model is shown here. The function of a minutia extractor can be further divided into three parts: pre-processing, minutia extraction, and post-processing. In pre-processing, we have three other steps: image enhancement, image binarization, and image segmentation. Image enhancement is the process of making an image clearer, thus thereby making operations on the image much simpler. There are two methods that are being used in this project to perform image enhancement. The first method is histogram equalization. It increases the perceptual information of an image by expanding the pixel distribution. The original image is of bimodal type, whereas the enhanced image only occupies range between 0 and 255. This enhances the visual effect of the image. Images before and after histogram enhancement are shown here. Next method for image enhancement is Fourier transform. The image is divided into smaller images of size 32 by 32 pixels, and Fourier transform is performed on these. The formula is shown here. The FFT blocks are multiplied by their magnitudes so that the specific blocks can be enhanced by their dominant frequencies. The formula is shown here. By experimentation, the value of k was found to be 0.5. The formula for inverse Fourier transform is shown here. The images before and after Fourier transform are shown here. The next step is fingerprint image binarization. The process of transformation of an 8-bit gray fingerprint image to a binary image is called image binarization. In the resultant image, zeros are ridges and ones are furrows. The furrows in the image are represented in white color and the ridges are represented in black color. Images before and after binarization are shown here. Next step is the image segmentation. In this process, the region of interest is extracted from the image. The region of interest can be bounded and the remaining effective area is greatly reduced. The process is of two steps. In the first step, the block direction estimation. The algorithm to determine the block direction is as follows. The x-axis and the y-axis are determined for every pixel in the block. The task is completed using Sobel filters. The formula for this is given here. Once the calculation of block direction is completed, blocks that contain only background information are discarded. The formula for discarding is provided here. Images before and after block direction estimation are shown here. Region of interest extraction by morphological operations. Open and close operations are considered to be morphological operations. An image is expanded and peaks are removed by performing the open. Images are shrunk and small cavities are eliminated by performing the close. The uppermost, rightmost, leftmost and the bottommost parts of the image are discarded, just leaving the area containing the bound and the inner area of the image. The images before and after morphological operations are shown here. The next step in fingerprint recognition is minutia extraction. The first step in that is ridge thinning, the process of eliminating redundant pixels of ridges until each of the ridges have a width of 1 pixel is called ridge thinning. MATLAB's inbuilt morphological thinning function is used in this project. Minutia marking becomes a trivial task after performing ridge thinning. In a 3x3 window, if a central pixel is 1, and it has 3 neighboring pixels which has 1 value, then it is a bifurcation. If the central pixel is 1 and it has exactly 1 neighboring 1 pixel, then it is a termination. There is a possibility that a single branch can be counted multiple times. A check routine has to be implemented to avoid the same. The fingerprint images are not completely healed by pre-processing stage. Some errors due to over-inking or insufficient inking are not eliminated. Sometimes there is a possibility that pre-processing stage can also introduce some elements that could eventually become spurious minutiae. All these can affect the accuracy of matching. Hence, it is essential to have some mechanism to remove false minutiae. The algorithm for false minutiae removal is shown here. If both bifurcation and termination have a distance less than d between them, then both of them are removed. Minutia matching is the process where two input images are acquired and determined if they are from the same finger. The algorithm adopted for minutia matching is 2 steps. The first step is alignment stage. One minutia from the input images are chosen and similarity between them is determined. If the similarity is greater than the required threshold, all the minutiae are transformed such that the x-axis is coincident to the direction of the reference point and the reference point is chosen as the origin. The next stage is the matching stage. Since two minutiae cannot be identical, the algorithm has to be elastic. The number of minutiae pairs that match are counted, and if they reach a threshold limit, then the minutiae are said to be a match. In this approach, each of the pixels are put into a bounding box. If the difference in direction is very small and if both of them fit in the same bounding box, then they are considered to be a matching pair. If the ratio of the matching pair to the total number of minutiae pairs is greater than the threshold, then the fingerprints belong to the same finger. Multiple MATLAB programs were developed to implement the fingerprint recognition system. The operations that will be performed are loading an image from a database, performing histogram equalization, Fourier transform, image binarization, block direction estimation, region of interest extraction, ridge thinning, and minutia marking, and false minutia removal on the input image. After 2 images are chosen and minutia features are extracted, minutia matching is done. A separate program to integrate all these functions has been developed. Let us move on to the MATLAB simulation now. This is the code developed for the user to interact with the fingerprint fingerprint system. When a user runs the code, a fingerprint recognition system is launched. The user can load an image from a database and extract the features by performing the operations such as histogram equalization, Fourier transform, image binarization, direction estimation, region of interest extraction, ridge thinning, and then extraction. The real minutiae are extracted here. Once an image has been extracted, it is saved as a data file. Another image like this can be extracted, performing the same operations again. Once two of these fingerprints are chosen and minutiae features extracted, they can be compared to show a percentage of match. These two pictures have a 36.36% matching percentage. If I happen to compare two of the same, I will get a 100% match. It is shown here now. By successfully developing the above mentioned programs, the fingerprint recognition system was implemented. Once the file is started, the fingerprints can be loaded into the program from a database. The loaded image can then be processed to get a .dat file which contains the minutiae information of the image. This process can be repeated for more than 2 fingerprint images. Once at least 2 of these DAT files are generated, they can be loaded and matched against each other to get the matching percentage. A screenshot of the MATLAB simulation is shown here. Experimental results are being discussed now. The fingerprint recognition system was tested using the fingerprint verification competition database. The project tested all the test images without changing the database. The results show that the project can differentiate spurious minutiae from the real minutiae. This graph has two histograms, the red one and the green one. The red one shows the incorrect scores and the green curve shows the correct scores. From the graph, we can see that the peak of the green curve is to the right of the left, which implies that the fingerprint recognition system can differentiate fingerprints with high accuracy. Let's move on to the summary and conclusion. The fingerprint recognition system was implemented in MATLAB. The implemented system is able to perform the pre-processing tasks such as histogram equalization, Fourier transform, image binarization, etc. The system is also able to perform minutiae extraction processes such as ridge thinning and minutiae marking. The system can also perform post-processing functions such as false minutiae removal. Finally, the system can perform the matching between 2 fingerprints and give as output the similarity percentage. The performance of the system was tested using the fingerprint verification competition database and produced satisfactory results. In the future, studies can be conducted on better designs of training and thus improve the results. These are the references I have used to implement the fingerprint recognition system. I would like to thank you for this opportunity. Thank you.